Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and this is lecture number 23 on chemical kinetics. In this lecture I will explain one more numerical for determination of order of reaction and energy of activation. So first of all, let us take one numerical. From the work of two students on the action of bromine on fumaric acid. The following data were obtained. For first student, the data is time in minute and concentration. At 0 time, the concentration is found to be 8.88 and at 95 minutes, the concentration is 7.87. For second student, the time in minute and concentration. So at 0 time, the concentration was found to be 3.81 and at 132 minutes, it was 3.51. Okay. Well, some more informations are given, like mean concentration is given. For first student, it is 8.37, and for second student, mean concentration would be 3.66, as well as minus dC1 upon dt for first student is 0.0106 and minus dC2 upon dt for second student is 0.00227. So this information is given and you have to find out order. Find out order of reaction. Now from informations we come to know that which kind of method we should use to find out order of reaction, and here differentiations are given, so we use differential rate law, okay, to find out order of reaction. So differential rate law is used for this one. Method is used, and for that the formula is n is equal to log minus dC1 upon dt minus log minus dC2 upon dt upon log C1 minus log C2. So we substitute values of all. N is equal to log 0.0106 minus log 0.00227 upon log 8.37 minus log 3.66 and find out n. Okay, n can be 1, 2, 3, whatever. If it is fractional value, we'll have to see whether it is greater than 1.5 or less than 1.5. And likewise, we can find out order of reactions using this formula. Okay, now we'll go ahead with a new topic of energy of activation. It is written as EA. Okay, so for that, let us take one reaction. A2 plus B2 gives twice AB. Suppose this is the reaction. Now, according to thermodynamics, we will see, suppose there is single bond between AA and BB, and now we will get 2 times AB. It's like H2 plus Cl2 gives 2HCl. Okay, for this reaction, here we can say that there is a bond between AA and BB. Now, if we want to carry chemical reaction, we have to try to get chemical change, and for chemical change we have to give energy to break these bonds. So bonds are broken. For this, bonds are broken and new bonds are formed. Then we get products. So this is basic of chemical reaction, that if you want to carry chemical reaction, we have to break bonds. Okay, so let us understand this with graph. On y-axis we can put energy, that means if you go ahead then energy increases, and here on x-axis let us put the reaction in progress of reaction. Okay, we don't know what is the potential energy of any reactant. So we assume that suppose it is here that we have AA and BB and their energy is this much. This is known as energy of reactant. Okay. Now, when we give energy, the distance between A and A increases, B and B also increases, and energy of A2 as well as B2 increases. So the graph goes like this because reaction is in progress. So we go in this direction. Okay. Well, A2 and B2 will absorb energy up to certain extent. Okay. When A and A goes away from each other, maybe at infinite distance, and B and B also move away from each other up to infinite distance. Now there is no attraction or repulsion between 2A and 2B. Even there is no attraction and repulsion between A and B and A and B. So here all atoms are free. Okay, this is known as transition state. And this is kind of complex called activated complex because we have given energy, so the molecules are activated state, excited state, so it is called activated complex because it is neither product nor reactant, and this is due to energy. And you know that when energy is given, repulsion takes place and therefore distance between atoms increases. At this moment, if A attract B or B attract A, that means due to attraction energy decreases, and therefore again we'll go ahead because of progression of reaction, and here energy goes on decreasing because of attraction. Okay, well, it can go up to this way or up to this here also, depends. Okay, it can be here also or here, anywhere, doesn't matter, but energy decreases because of formation of bond between A and B. Okay, so here either 2AB appear here or 2AB appear here, but in these conditions energy decreases. Okay, so This way reaction proceed. Well, in this reaction, you can see that if you want to carry reaction, that means we want products. So minimum this much energy is required to give. Okay, and this energy which will bring product or reactants in transition state is known as energy of activation. Okay, this is called energy of activation. So energy of activation is the minimum energy necessary to cause a reaction between colliding molecules. Only molecules that collide with a kinetic energy greater than EA, energy of activation, are able to get over the barrier and react. And that is why we get product. Okay, so this is the conditions to get the products. Okay, that means A and B should collide with each other, first condition, and second condition that they should have minimum energy of activation and at this level. So when they form activated complex only, then and then A and B can combine and form AB. Okay, if AB collide over here somewhere between this range, product cannot form. Okay, minimum this much energy required, then and then we get product. So this is about energy of activation. Okay, thank you so much.